Okay, I'm now going to ask our present speakers to join me up here, and we'll take questions about any of the talks. Any questions that you have or comments. There are a couple of microphones so that we can hear you clearly. There's Dina. No? Can we turn on the mics and on the stairs, please? Try again.
No. So a question for Marc. The robots you show, they're quite similar to like how we see humans or other animals move. They're 2 legs, they're 4 legs. Do you think like as we advance with this kind of stuff in the future, we'll see very, very different types of locomotion? Or do you think that like what biology has evolved is more or less what we also will end up using?
So first of all, I don't think people have been asking me, are humanoids the way of the future? And I don't think that human form is necessarily the practical form for doing many things, despite the argument that humanoids fit in the places designed for humans. I think lots of things can fit into those places. But, you know, again, if you go back to my weakness of why did I do the performing robots, there is something about the response and the reaction to humanoids that make them have an impact that sometimes other robots don't have. But to your question, whether or not the biological solution needs to be the engineered solution, I mean, it's very hard. You know, we don't have yet the materials, the signals, the computing that biology has. You know, some of those dimensions are advanced. We don't have the energetics and the energy production that animals have. Some of those things we're making progress on, probably mostly on the computing side, although maybe not in the same package size computing. But I think that many of the principles are the same. You know, the physics are the same. I think it's certainly inspiration. So I think there can be a lot of similarities. But it doesn't have to be the same answer.
Okay, other questions? Comments?
It's definitely not used building.
Yes, please, up there.
Battery-powered robot as opposed to a human energy.
Well, some people say that a human can I wish I could remember exactly what the quote is, something about how little food they need to walk all the way across the country, whereas Spot goes for about 90 minutes. I'm sure that Spot could be designed, and they're actually working on improving the efficiency to be maybe 10 times better without there being a miracle. It's definitely, you know, one of the old world problems that's right at the center of making robots practical. You know, how long they can go on their energy. You know, we're getting by with battery technology. Battery technology is getting better. The early robots I showed were powered by gasoline engines because gasoline is so much more, or gasoline or diesel is so much more energy dense. But there's a lot of downside to doing that, too.
Other questions? Yes, sir. You.
Why does the black hole have 3 bright spots?
The question was, why does the black hole have 3 bright spots?
Yeah, good question. So really, you shouldn't pay too much attention to those bright spots. So if you remember, I showed from the data that we have, there are many, many images that fit the data and that are slightly different in what the images look like. And so some of those images, it does come out, there's kind of bright spots there, and in other images it's not there. But also because we're trying to take a still image of something that's really moving, right? So there are sometimes like artifacts that come out. So I think we can't say for sure whether those bright spots are really physically there or they're just an artifact of the imaging process. I think the main takeaways are that there's a ring, and kind of the diameter of the ring, and not so much with the SAIL20 work, but more with the M87 work, we trust the asymmetry in the brightness, like the bottom is brighter than the top. But for SAIL20, because it's moving so fast, we don't even trust that for that.
And just to follow on, we're not seeing so much, tell me if this is true,
Yeah.
we're not seeing so much a picture of the black hole as what it does to the universe around it, because the black
Yeah.
hole is the thing we don't see in the middle,
Yeah, it's
right?
like the imprint of the black hole on the surrounding emission. Yeah,
Okay.
so, yes, exactly.
That's a good way to put it, the imprint of the black hole.
Well, I had a question for Zach. It feels like in medicine you had to make so many investments earlier that paid off longer term, like the investments in understanding how to collect data, how to clean it, how to use it. What are you investing in now that will help us in the future?
So I think what we need to investigate now, what we are investigating now, is actually the interface between artificial decision makers and human beings. I think the likelihood is that we are going to be joined at the hip for a long, long time. For a variety of reasons, it's unlikely that AI will be fully autonomous in healthcare for some time. And so the question is, how do human beings relate? And on both sides, ChatGPT was released to the public, and I can tell you for a fact that many patients are using it already, whether or not it's been designed that way for diagnosis. And likewise, doctors, whether or not their institutions endorse it, are using it both for their administrative tasks, like getting pre-approval, as well as for getting decision support. Those interactions are a new, perhaps one of us said it already, a new kind of social construct, and understanding ways to improve and ways to debug that construct, I think are going to be essential to effective and safe use. And we're really just beginning, and what's amazing right now is what a Wild West we're living in. So it's, for students, a great time to study this new sociology of human and AI.
Other questions? Comments? Okay, then let's thank our speakers.